Hi, my dear NEET aspirants. Welcome to Bhanu Academy of Objective Physics. This is video class number 11. We are going to discuss center of mass hints for NEET entrance point of view. So it will be very useful to the students, those who are going to write NEET entrance examination on 7th May 2023. Okay, let us start center of mass concept clearly without delay. Generally, for objects, center of mass means it is a point at which total mass of the body is supposed to be concentrated. For symmetrical bodies, say for example, ring, equilateral triangle, square, cylinder, uniform cylinder, these are called as symmetrical bodies. In these bodies, mass distribution will be uniform. If the mass distribution is uniform, then center of mass lies at the geometric center. So these points represent center of mass, geometric centers there. And in the case of a ring ball, the total mass is concentrated on the ring, you know that. But at the center, at the geometric center, there is no mass, but center of mass exists. So, I am giving one sentence to you. It is not necessary for the mass to be present at the center of mass. Even though there is no mass, center of mass can exist. Example, ring ball, bangle, hollow substances. But in the case of a cricket ball, inside a solid material is present. So it is a solid sphere. Example, earth, cricket ball. Inside also mass is present. In such a case, center of mass lies inside here. In this case, center of mass lies outside. This can be treated as outside. It can be treated as inside. Okay. So this is the information about center of mass concept. So center of mass position depends on mass distribution inside the body or outside the body. Okay. In a body. Now our second concept is, if two masses are separated by some distance, M1 is heavier to M2. Two masses are given. The center of mass generally lies towards the majority. Along the line joining them, center of mass lies nearer to heavier mass. Remember this point. Center of mass lies nearer to heavier mass. So if mass is more, distance of center of mass is less. The position of center of mass is less towards the heavier mass, and it is more from the lighter mass. Then balancing condition is, for center of mass balancing condition, M1 x1, this product is equals to M2 x2. If all the parameters are given, masses are given, x1 position of CM from mass M1 given, that is 2 meter, what will be the position of center of mass from M2? They are going to ask. My dear NEET students, this is an important formula. Condition for balancing of center of mass. M1 x1 equal to M2 x2. Okay. Out of 4 parameters, 3 parameters will be given. 4th parameter you can calculate, that is position of CM from M2. My dear students, this is the third concept I am going to present. Now, two masses of mass M1, M2 are given to you. They are separated by some distance. And remember that the two bodies are at rest position initially. Then their center of mass will also be at rest position. Of course, it is nearer to heavier mass. We are assuming that M2 is greater than M1 now. So center of mass lies towards M2. Now my question is, if the two masses are approaching each other due to their mutual attractions, the two bodies are approaching each other due to mutual attraction, then what happens? With velocities v1, v2, they are approaching, but the center of mass continues to be at rest position. Even though the two masses are moving with the velocities, respective velocities, mass is given, velocity is given. Due to mutual attraction, they are approaching. Velocities are given. Then what will be the velocity of center of mass? They will ask. Remember that initially the two masses are at rest position. Center of mass also will be at rest position. Now, in the second case, even though they approach each other due to mutual attraction, center of mass remains at rest position only, does not move. Neither move right side nor move left side. Reason? Because center of mass motion does not depend upon internal forces. Because these two mutual forces are called as internal forces. They are action-reaction forces. They cancel each other. So the net force on center of mass is 0. If net force is 0, its acceleration is 0. Then the body is said to be either at rest or of uniform motion. So my dear students, remember this concept also very important. Velocity is given, mass is given. Then what is the velocity of center of mass? 0. Velocity of center of mass 0 because it continues to be at rest. In this case. Okay, my dear students, this is the fourth concept I am going to present. It is an equilateral triangle. Three masses are given to you. First mass, second mass, third mass. They are placed at the corners of an equilateral triangle. Each of side length A. Masses are mentioned here 1 kg, 2 kg, 3 kg. And side length also mentioned 0.2 meter. Okay. So then what happens? If side length is given, masses are given, question is what is the position of center of mass? So this is the position of center of mass because M3 is heavier, M3 is greater. So center of mass does not lie at the geometric center. It does not lie at the centroid. So it will be shifted towards heavier mass a little bit. So nearer to this body, center of mass. Now my dear students, they are going to ask, locate the center of mass. Find the position of center of mass. Then we have to assume that first mass is assumed as origin, at origin here. Second mass is at a distance A, and this is the third mass. Now we have to locate the coordinates of three particles. First particle is at origin, okay? First particle is at origin. So then 0, 0, x1, comma, y1. Second particle coordinates from this origin, a, comma, 0, you know that. And because this is the third particle coordinates a by 2, because this particle is at a by 2 distance. So you see, this is the median, you know. So from here to here, this is a by 2. Position x coordinate, x3, a by 2. And y3, from here to this particle y3. So this is median, root 3 by 2a. So if you know side length, you can find out coordinates of three particles. Once you locate the coordinates, then formulas are here. Position of center of mass, xcm, ycm. If you substitute these formula values in these two formulae, you can get xcm, ycm. That is called as position of center of mass. Okay, center of mass coordinates these are. My dear students, this is a square problem. It is also depending on the same model. Okay, four masses are located here at the four corners of a square of side length A. Then we have to locate four coordinates. This particle is from origin at A and A here, and this particle is not on x-axis. So that's why 0, A. So this is the information, my dear NEET students. So how to calculate the coordinates of center of mass? Okay, Now, my dear students, this is the next method now. In this method, okay, we are going to project some more important models in center of mass, right? Okay. Now, this is a circular disc. A circular disc I am giving now. Its radius is R, capital R. R1 equals to R. From this circular disc, a smaller disc is removed. A smaller disc means I am replicating here. This is a smaller disc. Its radius R2 equals to R by 3. Say for example R by 3. Okay, 1/3 of this radius is 1/3 of this radius. From a big disc, circular disc of radius R, a smaller circular portion of radius R by 3 is removed. Is cut from this disc. Then what will be the shift in the center of mass? So initially center of mass was here at C1 and its center of mass C2. Now C1, after removing this part, C1 will be shifted towards left side, opposite side by a distance x. So x represents shift in the center of mass. So what is the formula for shift in the center of mass? So that is m2 into d over m1 minus m2. My dear students, you remember this formula, general formula. So from a disc of radius capital R, a smaller circular portion of radius R by 3 is removed. Then center of mass will be shifted in opposite direction by distance x, which is called as shift in the center of mass. So that is m2 d by m1 minus m2. So my dear students, how to find out m1, m2 here? So m1 is volume into density. Volume is area into thickness into density. For the circular disc, area is constant, and for the circular disc, what are constants here? For circular disc, so thickness is same and density is same. So both are made up of by same material, you know, that's why density is constant, and thickness of these two circular portions is same. So then m1 proportional to A, m1 proportional to A1, A1 means R1 square, m2 proportional to A2 means R2 square. Pi r square, pi is constant of course. Now my dear students, finally what we will get? R2 square into R1 minus R2. This is the distance between two centers over R1 square minus R2 square. So this is the information about shift in the center of mass. What is D here? D is the distance between the centers of these two discs. Okay, so bigger disc and removed disc. So distance between these two centers, that is R1 minus R2 of course. Okay, so you can substitute here. So R2 square means what is this? R by 3 whole square you can put here, and R square means R square minus R by 3 whole square. So finally what we get? R by 3 R square by 9 into R minus R by 3 over what happens? R1 square means R square minus R square by 9, R by 3 whole square. You will get the final answer. Okay, by doing calculation you can get final answer. So this is R cube by R square by 9 into 2R by 3, R square by 9 into 2R by 3 over 8R square by 9. Final answer, what happens now? Tell me. Final answer. Shift in the center of mass. Okay, 9 gets cancelled. So R square gets cancelled. Then what we will get? 2R over 8 3s are 24. So R by 12. This is the answer. So 3 comes down, 24. So 2R by 24 means R by 12. So shift in the center of mass is R by 12. Okay, my dear students. So this is a removed portion. Suppose if this smaller circular part is added, added means what here? You have to write plus here. Added means added. This is removed problem. Smaller circular portion is removed, and here smaller circular portion is added. Added means what? Shift in the center of mass is m2 into d over m1 plus m2. My dear students, remember this point. So added means added or put over, we can call it as pronunciation. So attached. So this circular portion is attached additionally to this disc from outside. Okay. So attached means mass increases. That's why m1 plus m2. Removed means m1 minus m2. So my dear students, this is the information about shifting the center of mass in the case of a disc. Now the same concept spheres they will ask. So a smaller circular portion is removed from a bigger sphere. In the case of a sphere, what happens? Similarly, two radii are given there. Removed problem m2d by m1 minus m2. Up to here it is okay. But for sphere, what is a mass? So mass is nothing but, so you see here, for sphere, mass is nothing but m is equals to volume into density. Volume means for a sphere, volume is 4 by 3 pi r cube. My dear students, you remember this point. So 4 by 3 pi is constant, rho is constant, m proportional to r cube. Okay, m1 proportional to r1 cube, m2 proportional to r2 cube, where r2 cube means r square by r cube by 27, because r by 3 whole cube, so you can put, instead of r2 you can put r by 3, then you will get this one. Okay, so formula becomes x is equals to r2 cube into r1 minus r2 same as it is, by over r1 cube minus r2 cube. So my dear students, so this is important information. So they, in entrance examination, they may ask disc or sphere, whatever it may be. Okay. So removed problem means minus. Added problem means put over problem means added means removed means minus here. Removed means minus here. In the case of a sphere, removed means minus. In the case of a disc, removed means squares. For a disc, squares formula. For a sphere, a cube formulas. You have to substitute. Okay. So wherever it, whatever it may be, d value, say distance between the centers of these two, that is r1 minus r2 always. Right. Very important. Already they asked in entrance examinations, previous entrance. One more important concept from center of mass I am going to present. What is that? T problem. This is a T problem here. This is called T problem. 2 centimeters. This is one more T. So 2 centimeters, dimensions are given there, and it is 8 centimeters given, and this is 6 centimeters given. This is a point. My dear students, locate the center of mass for this T problem, T-shaped problem object. Okay, locate the center of mass for the above object. Above T-shaped object. Dimensions are mentioned. Okay, its length is 8, its length is 6. Okay, edges are 2 centimeter, 2 centimeter, and point is given with respect to point O. This is the information. My dear students, first we have to find out how many parts are there in this object. So I am dividing two parts now. Here, this is the first part and this is the second part. My dear students, you observe here, the T-shaped object is divided into two parts. That is step number 1. In step number 2, we have to identify the center of mass positions. So for this uniform distribution, so that's why it is center, C1. And for the second part, it is also uniformly distributed body. So that's why center of mass lies at the center. C1, C2 we have to locate. This is step number 2. In step number 3, what we have to take here? In step number 3, coordinates we have to identify. So this is x1 comma y1 equals to, x1 means from origin to this point, that is 1. From origin to this point, that is 3. My dear students, we located the coordinates of center of mass. Next, coordinates of center of mass C2 we have to identify. So from this point only we have to calculate. Okay. So from here to this mass is again 1. x2 comma y2 is again 1. From here to this point. From here to this point. So here 6 plus 1. 6 plus 1 is how much? 7. So these are the coordinates of second one. Okay. So once you selected the coordinates and masses also. M1 equals to, this is a square rectangle, you know, length into breadth, no, area. So mass proportional to area. So area is here 6 into 2. 6 into 2, that is 12. That is mass number 1. Mass number 2, that equals to second piece, 8 into 2 dimensions. 8 into 2 areas, that is 16. Now I am writing XCM, YCM. I am locating center of mass for the two system. So I am drawing the line here between these two centers of mass. Center of mass lies towards this point. This is center of mass. Its coordinates XCM comma YCM. Okay. If you substitute M1 x1 plus M2 x2 over M1 plus M2, you can do this calculation. You will get 0 because masses are given there 12 and 16. Coordinates x1 means 1, y1 means 3. You can substitute x2 value 1. Okay. So you will get 0. Right? And second point is m1 y1 plus m2 y2 or something values. Okay, we have to net m2 y2 over m1 plus m2. So you substitute all these values. So m1 is what? 12 into x1 is what? 1. Plus m2 is 16, x2 is 1 over m1 plus m2, 12 plus 16. Then you can calculate. Similarly, 12 into y1 is 3 plus 16 into m2 into y2 is 7 over 12 plus 16. You can do the calculation. My dear students, this is a method to locate center of mass for T-shaped problem. Similarly, for F-shaped problem also we can locate the center of mass. Because F-shaped body is divided into 3 parts now. So 3 centers of masses you will get. For those 3 centers of masses, we have to identify XCM comma YCM. So this is a method of calculating center of mass position, identifying center of mass position. So my dear NEET students, you are going to write entrance examination in the month of May. A date has been announced by NTA, that is 7th May. Okay, so you are going to write that examination. Wishing you all the best. I am projecting chapter wise, day wise video classes, conceptual video classes and hints which are helpful to you in entrance examination, I hope. Okay, so if you like this video, if you are very much interested in hearing these videos, you like, share and subscribe these videos and press the bell button, don't forget that, and share this video to all your nearby students, near and dear. Okay, so my dear students, in the next class, that is tomorrow only, I am going to project a gravitation concept now, or torque and angular momentum. So many topics are there. So tomorrow let us do one thing, torque and angular momentum concepts I am going to explain in the video class number 12. Okay, bye, see you till then.